Hello and welcome to Scientifically Speaking. Today's epic. I have described quantum mechanics and I have described the subatomic level of atoms. And on November the 11th, 2021, everything I've ever said is confirmed, and every single detractor and stealer of my work is confirmed to be a lying, stealing fool. So here we are today at phys.org, and we are looking at the first observation of an inhomogeneous electron charge distribution of an atom. Now, inhomogeneous means asymmetrical, which means not the same. And that's what it looks like. We're going to see a little movie in a minute of how it's built up. And then I'm going to go through my work and show you that all I've ever said is vortex to rollover halo wave. And we will go through some of the crazy stuff that I wrote that people laughed at, made fun of, called me horrible names, said I was a crackpot, and all the horrible stuff that they've always said about God's people. So let's check out what it says. Until now, observing subatomic structures was beyond the resolution capabilities of direct imaging methods. So this was never seen before. I said I'd seen it in visions, and I drew it. Czech scientists, however, have presented a method with which they became the first in the world to observe an inhomogeneous electron charge distribution around a halogen atom, thus confirming the existence of a phenomenon that had been theoretically predicted but never directly observed. So I had theoretically predicted it as well, and I drew it. Comparable to the first observation of a black hole, the breakthrough will facilitate understanding of interactions between individual atoms or molecules, as well as of chemical reactions, and it opens a path to refinement of the material and structural properties of various physical, biological and chemical systems. The breakthrough will be published on Friday in Science. And as I've always said in my video of Base Code of the Universe, it applies to physical, biological and chemical systems, which means all the work I ever did, me saying it could be applied to the physical, biological and chemical systems, is now again proven correct. Okay. The Technical University of Ostrava have succeeded in dramatically increasing the resolution capabilities of scanning microscopes, blah blah blah, theoretically preferred. Confirming the existence of the theoretically predicted sigma hole is not unlike observing black holes, which had never been seen until only 2 years ago, despite being predicted in 1915 by the general theory of relativity. Now, Einstein was wrong in pretty much everything he said, so we'll just kind of put that by the side. Viewed in this sense, it's not much of an exaggeration to say that the image of the sigma hole represent a similar milestone at the atomic level. Until now, the existence of the phenomenon, known as sigma hole, had been directly demonstrated by X-ray crystal structures with a halogen bond, which revealed the surprising reality that chemically bonded halogen atoms of one molecule and nitrogen or oxygen atoms of a second molecule, which should repel one another, are in proximity and thus attract one another. This observation was in blatant contradiction with the premise that these atoms carry a homogeneous negative charge and repel each other through electrostatic force. So experiment and theory pictures, and anybody who watches my channel knows exactly what that is because they've seen it in water. This led scientists to examine the subatomic structure of halogen using Kelvin probe force microscopy. Now, Kelvin is a temperature measure, so we're looking at heat, energy. They began to develop a theory describing the mechanism of the atomic resolution of the Kelvin probe, which allowed them to optimize the experimental conditions for imaging sigma holes. The subsequent combination of experimental measurements and advanced quantum chemical methods resulted in a remarkable breakthrough, the first experimental visualization of an inhomogeneous electron density charge distribution, i.e. a sigma hole, the definitive confirmation of the concept of halogen bonds. So, anybody who's just seen that picture knows that I've already drawn a sigma hole and I used it in everything. But we'll get to that. We improved the sensitivity, blah, blah, blah. When I saw the sigma hole for the first time, certainly skeptical, it implied that we'd overcome the resolution limit of the microscopes down to the subatomic level. Again, okay, according to scientists, the ability to image an inhomogeneous electron density charge on individual atoms will, among other things, lead to a better understanding of the reactivity of individual molecules and the reason for the arrangement of various molecule structures. So they're just on about imaging it. All right, so this is how they imaged it. So this is, let's say, bromide atom. Does it say there? No, anyway, this is going to image it. So let's watch. I'll probably get a copyright strike for this. So no payment for one of the best videos in the world. That is the sigma hole. The distribution. So above that is the electron energy charge. They scan it, and it gives you a frequency shift. Red and blue mean towards or away. Then it scans it. As we see, there's a hole. What are you looking at? I see a vortex to a rollover halo wave, a sigma hole. The characteristic shape of the sigma hole is formed by a positively charged crown. Remember my video? The king wears flowers in his hair with crowns, surrounded by a belt of negative electron density. This homogeneous charge distribution leads to the formation of a halogen bond, which plays a key role in, among other things, supramolecular chemistry, including molecular crystal engineering, and in biological systems. The precise knowledge of the electron charge distribution on atoms is necessary for an understanding of the interactions between individual atoms and molecules, including chemical reactions. Thus, the new imaging method opens the door to refinement of the material and structural properties of many physical, biological and chemical systems affecting everyday life. And this is what I said years ago. I said in the base code of the universe, because that's what it is, that everything, absolutely everything, is an electrochemical reaction. Because it's an electric that applies to chemicals that creates the reaction. It's an electrochemical reaction, and that is every process in the universe, vortex to rollover halo wave. Just so everybody knows, I've shown this travel in gases, solids, liquids, every form of matter. I have shown this travel in and used vortex to rollover halo wave for every single explanation. Now my work is in no particular order. I just grabbed about 20 pictures so I could go through them. So here we see Birkeland currents on a magnet, HD close-up. That was my video. That was in 2017. What I need you to look at is the top part of the page there. And what do we see? We see trumpets and a top version of the halo wave right there. And what do we see? We see basically it's a vortex to a rollover halo wave, and that's why I then drew the trumpets. All the rest on there is all energy travel and all the different forms of energy travel that energy can make. But as I've said in many videos, when energy meets an energy or matter barrier, it must perform a rollover halo wave. This, of course, is my base code of the universe that I did in December 2020. So over a year ago, I said this is how the whole universe is constructed. And as you can see on there, there's a side view and a top view, and we have God's sign. And both of them are vortex to rollover halo wave, which is exactly what we're looking at here. Okay, so I probably should have started with this one, but I made a couple of videos and I said God showed me the electron. I said I sat there, and because I was visualizing everything like 7 years ago, in the visions, everything I thought of just went blam, burst out of my head. So I said, Lord, can you show me the electron? And everything was darkness, and I saw an electrical strike with a cup on top, like a hand holding something, but there was no electron there. And I went, that's weird, Lord. And I didn't trust what had been shown, and I've had that for years. But I finally released it on God Showed Me the Electron, April 26th of this year, 6 months before this report of the electron density charge came out. And as we can see, it's inhomogeneous, which means it's not symmetrical, and it's got that rollover halo wave on top. It's got the cup to the vortex. So, yeah, I was almost embarrassed about putting it up because I thought, anybody who says, what's an electron look like? It's a round ball of some form. Well, it's not. And I didn't think it was. It's a rollover halo wave, which, as I've said in previous videos, can become a halosphere. And I've done a video on that about atom cloaking, where the rollover halo wave goes up and then it comes down. The energy ejection is stopped, so the bottom point of the vortex lifts off, goes into the halo wave, and if the halo wave spins down and around, you get a halosphere. So, yeah, I asked God to show me the electron. He showed me what was holding up the electron. This was just part of one of the books that I've been putting all my work in. And again, as we see, rollover halo wave, in the center of the picture there, you see how it turns into a halosphere, where the rollover halo wave drops below the actual input emission and then joins to form a halo wave. And again, we can see the halo wave from the top, which is exactly the same as that electron distribution charge. Now, I've shown all these pictures in water,